Hey everybody, this is Todd Frazee, and we are going to be modeling the stop block, which is on page 681, figure 13.42. In this exercise, we're going to reconfigure the user coordinate system. So I'm not sure if you've done that, but that might be something new for you. I've had to make a few assumptions on this design because there's not enough detail in the isometric view they've provided to know what's going on the back of the part, what's going on there. So we're going to roll some assumptions I'm going to make, and some of the dimensions we need to derive at as we build it. So there's lots of ways to develop any of these models, but I'm going to take an approach of taking what would be the front view in my mind and starting there because it has a pretty good section we can extrude as our first entity. So here we go. We're going to start off in world. We're going to start off in the front view, and I'm going to use a series of lines, and we're going to place the origin, the corner of the part where the 9.2 dimension radiates from is going to be our starting point. So we go from origin, and we want ortho on. Draw a line to the left, and we're going to then draw a vertical line. Okay, I'm going to turn the grid snap off at this point, now that we have those two lines established. And we're going to offset the first one 3 inches, because the overall height of the part is 8, and then the vertical flange on the right side of the part is 5 inches, so that makes the difference 3. So we're going to do an offset of 3 inches and offset for the thickness of the part. Now in the opposite direction, we're going to hit enter and go back into the offset command, and we're going to put in 9.20, which gives us an intersection of the corner. Okay, so we're going to extend the horizontal lines if they're too short, and then trim off the vertical lines. So we should have a rectangle that's 9 inches and 9.2 inches long by 3 inches tall. Okay, now we don't know the length of this tab, or we don't know where to locate this corner in reference to the length of the tab without developing the tab, the angle tab. So we're going to do that next. We're going to draw a line from the bottom corner that we know is at 9.2. And the angle of this is 30 degrees, but we need to put in the complement, which is 150. We're not going to set a length. We're just going to set the complement angle. So 150. I'm sorry, negative 150. And that gives us this line here. We are going to offset that line by the thickness of the tab, which is 1.5. And that gives us the opposite side of the tab. What this allows us to do is descriptive geometry to project back to where this angle is, because intersects. We don't have a dimension for that. Okay, once we've extended that, we can trim off the corner and delete this vertical line. Now we need to set the length of 8 inches. So the length of this is set off the top corner. We're going to use a line, and we're going to go over to object snaps, and we're going to use perpendicular. So make sure perpendicular is selected. Actually, we're going to drag down until it snaps perpendicular to the line we drew. Okay, we just need that line, and we are now going to offset that line by 8 inches. Okay, now that we've offset by 8 inches, we've established the length of the part. We can hit escape and then delete the one line and trim the others. I'm going to show you power trim. You click and drag, and everything the path crosses trims off. Kind of neat. All right, so now we need to add the slot that's in this face. So to do so, we'll do an offset, and we're going to go 0.95 to offset the bottom edge up. We're going to put in 2.94. We're going to offset the right side edge. And we're going to enter the offset command again, and this time we're going to change the value to 2.55. And that gives us the slot width. Now we're going to come back and trim off the elements we don't need. And we have our profile for our first base feature. Okay, we're going to use the press pull command so we don't have to make a region. We're going to drag it to the left, and our part is a width of 6 inches. There we go. So over here, if we switch to shaded with edges, you should have this. Good time to save. I'm going to go back to wireframe. Okay, we're going to draw the flange that goes on the opposite end of the part. To do so, we're going to do an extrude, and we need to change the top view. And in the top view, we'll go ahead and move back to a 3D view, but we want this set for top. We're going to draw a line from origin, and we're going to go some distance, about 5, fine. But we're going to go select tab. We're going to select tab to set the angle rather than selecting another point. And that angle is 30 degrees. Now that we have the 30-degree angle established, we can then offset for the length of our rectangle we're going to make, which is 5.82. And after we've done that, we will connect the endpoints from origin to the left side. This will allow us to have a line then to offset for the thickness of the flange, which is 1.88, 188. And then we will trim up the rectangle we just made. All right, because we're going to use the extrude command rather than press pull, what press pull does is if part of your profile is outside of the part and the other part's inside, it tries to cut and extrude. It can't try to do both. And we want to extrude these two bodies together and then make them one. So in this instance, we want to use the extrude command. So we'll go to the region, and we'll create a 4-line region. And then we're going to go to the extrude command. And we'll accept the region, and we're going to go up 8 inches. Okay, so we now have 2 bodies, and we're going to merge those bodies. So we'll take the top one, bottom one, and merge them into one. Okay, this is another great opportunity to save. Now what we need to do is cut off this triangular section that's in the back. It doesn't show it in the drawing, but I believe it would make sense if this is a surface that a keyway is going to sit on, that this should be flat. Now, if we zoom way in, we notice there's a little gap here. So we need to develop a triangle. We can't just use straight press pull because we need to close up that region. To do so, we're going to draw a line from this vertex to the opposite vertex. Then we're going to draw a line from that same original vertex to the left corner. And then we'll draw another line that's going to go shoot past. And at this point, we're going to turn on ortho so that we make sure we're 90 degrees and draw the line to the right. Can't really see it because it's on top of the solid. What this will allow us then to do is do an extend. If we did everything right, we should be able to extend the first line we made, and it'll extend the triangle out to where this line is. We will then use the trim command to trim off the extra piece of the extra long line there. We should have everything we need for the region. We're going to go press pull. We're going to select the triangle, and we're going to go all the way through the part, and we will put in a depth of 3 inches. Alright, so we've trimmed off the tab. We're left with the geometry for the triangle. We can now delete that construction geometry because we don't need it. Alright, moving on. And then we'll get into change our last two simple features, and then we'll get into changing the UCS. So the last two simple features are the slot in the flange, and there's a hole going through the top of this component here. So we want to continue to work in the top mode. Our slot that's in the top, we'll draw a line from end to end. We'll accept that line, and then we're going to do an offset of 1 inch. I accidentally went too far. Yeah, that's our 1 inch offset. Offset the line we just created. Offset the line we just created by 4.32, which gives us the one side of the slot. Then we repeat, exit and repeat the offset command for 3 inches. And now we can do some trimming. Okay, we should have the rectangle we need to press pull through the part. So we're going to go press pull. We're going to select the boundary of the rectangle. And we're going to go all the way through the part, which is 8 inches. Alright, so let's delete this extra construction geometry we don't need. Alright, so your model should look something like this. Okay, so now we're going to put a hole in the top face here. Now I noticed, I modeled this once before, I noticed the hole, it's not clear in the drawing, but this hole actually intersects with the one of the inside faces of this slot. So I'm going to opt to put the hole all the way through the part as opposed to having it terminate at the slot. Okay, so to do so, we need to again create some construction geometry. We're going to create a line. It's going to go from this intersection, and we want ortho on at this point. And we'll just go past the part. And then we need another construction line to go from this same point all the way out another axis. And we'll offset those two lines to find the center of the hole. So we'll use offset, and we're going to go a distance of 4.7 with the first line. And then reset the offset to 1.85, and we offset in the second line. So this intersection of those two lines that cross will be where our circle goes. Make sure that your O snap for intersection is enabled. You're going to drag out, and we're going to do a diameter of 1.85, and that's our circle. Press pull. Three inches, it should go all the way through the part. You should have a result that looks like so. So if we were to switch to shaded with edges, we have a hole that comes through that partially intersects the slot. All right. So let's go back to wireframe. And let's delete these two pieces of construction geometry. It's good house cleaning. So the next step is to place the hole in this face. And this is why an auxiliary view would be used. Auxiliary view looks at the face at the angle normal to it. So to define where the location of the hole and the diameter, you would need to have a view on your drawing that's normal. The equivalent in CAD is your user coordinate system. So we're going to take and we're going to redefine our user coordinate system by using the UCS icon. It's going to ask us, where do you want to put origin? At this point I want to turn off ortho. But we're going to put, since we're going to do the hole in this flange in this face that I have highlighted in blue, we want to operate in that plane. So I'm going to pick the left corner as origin. Then it's going to ask you where's a point in the x-axis. We'll pick the opposite corner on the right. And then it's asking for a third point that's in the xy plane. So we can pick any point on the plane we want to work on that isn't the one of the original selections. So it could be either here or here. And then it resets our user coordinate system to be working in that plane. Okay, so now we are working in the user coordinate system. It'll be looking straight in at that face. Okay, so now let's create some lines. We're going to create a line from origin, and we'll go ahead and turn ortho on. I believe it'll work. Now that our UCS is turned, we'll go past the part, and then we're going to go horizontal and go past the part. So we have our two construction lines from the edges that the hole is called from. Okay, we're going to go to offset, and we're going to set an offset of 2.91 for the horizontal offset. This line would go horizontal, and then we'll repeat the offset command. No, I'm sorry, the hole is offset from the top of the part, not the bottom. So we're going to create a new line, and we're going to go from the one corner out. And now we can go back to the offset command, and it's an offset of 2.38 that we need to reset it for, and we're going to offset down. Just so we don't have any confusion, I'll go ahead and delete that guy. So the intersection of that crosshair we just created is where the center of this hole is. It's the 1 inch 760 thousandths. So we're going to take and use the circle command, pick our intersection. You notice the circle should be in the plane of the flange. I'm going to type diameter, and we're going to put in 1.76 and hit enter, and there's our hole. Let's go through and delete our construction geometry. We don't need it. We don't want cluttering up our press pull. And then we're going to go to the press pull command, select our circle, and we need to go through 0.88 of material. And so we now have a through hole through the vertical flange. Great time to save. Our last feature to create is the dovetail in the front. It looks like it is intended to be a symmetrical feature, so I'm going to set up to draw half of it and use a mirror on the sketch. But first we need to change our UCS. So we're going to change our UCS again, and we'll go ahead and turn ortho off for the moment. And we'll pick the left corner. Then we'll pick the right corner as our positive X dimension. And then it's asking for a third dimension in the XY plane. So we'll pick any other corner of the plane we're going to work in, which is this one. Now the UCS is oriented so that X and Y is in line with this plane here. Let's create some construction geometry. We're going to go from origin. We're going to turn on ortho, which should snap to the user coordinate system plane we're in, and create a line from there. And we're going to create a line horizontally. So we have an offset of, on the drawing, of 2 inches. So we'll select that and offset 2 inches to the outside corner, the smallest portion of the dovetail shape. Now I want to create a center line to use for this. So we're going to do another offset, cycle back into it by hitting enter, and we're going to go 1 inch, which is half of the width of the dovetail, and we're going to offset to the right. So this is the edge of the dovetail, this is the center line of the dovetail, and then we'll use this center line to mirror 1/2. Okay, now we're going to go back into the offset command, and we need to offset in 1.94, which is the height of the dovetail feature. And now we're ready to draw a line. So we're going to draw a line, we're going to turn ortho off, we're going to select the corner that defines a small portion of the dovetail, and we're going to drag to the left past the last line we offset. And the dovetail is 60 degrees included, but we're working on the opposite side of the angle, which would be 120. And we got our line. I don't know why it shot out so far, but it should be in the plane that we're working in. Okay, so now we're going to come back and we'll go ahead and delete the vertical line that corresponded to that, and we're going to trim off the corners of the dovetail, and we'll trim it off to the center line we made. And I'm going to delete. Okay, so we have this dovetail geometry, and we're going to select 2D mirror. We're going to select our 2 pieces of geometry we're going to mirror. We're going to accept those. And our first mirror point will be the front center edge. Our second mirror point will be the other end. And do we want to erase the source? No. That way we keep the original. Right, so now we can delete this extra geometry, and we're left with a dovetail shape that we can use the press pull command on to press all the way through the part, which is 1.5 thick. And delete that construction geometry. And that should be it for this part. Okay, so here we go. Here's our part. Go to shaded mode. And all your features should look like as shown. Alright, that concludes this tutorial. And the next one we'll be doing auxiliary views and dimensioning this part. But that'll be in the next unit. Thanks a lot, and I'll see you on the web.